And we are live. At least we should be. Starting. Okay, let me check. We are live. Okay. At least. Okay, I don't need this anymore. So let me get the link. Also, hello everyone, and welcome to another live stream. And today we will be finding the way through multiple gateways, as suggested by the, how do you call it, by the title. So I have the top chat here. I will try to keep an eye on it in case anyone actually uses it. But for now, let's spam the. Oh, Karsten is saying something. Maybe should I read it? Oh, there are some. Oh, okay, whatever. Okay, let's share the link, which is stream Creeper World 3. Bam. You are already streaming? Oh, I didn't. I forgot to end the last stream. My bad. Well, let's not forget to end this stream after the stream is done. So let's get to it. Now, as you can see, there are a lot of regions and a lot of gateways. Now the units can find the way into a region next to one they are in, like this, right? So it will go through this gateway and then up here. So that's working fine. However, if I go over here, then it is not able to find the way because it is not smart enough to go through two gateways. So that's what I will be fixing today. Also, there might be multiple ways like this, in which case there is actually more than one path. And finally, what I also want to do is make it possible so that there's like one gateway in the same region. So imagine a gateway going from here to here, and then a unit can go through the gateway because it is faster when you move it somewhere. So maybe you have a map with just one big region over the entire map, and then some gateways in it so that your units can move faster. And you don't even have separate regions like this. Also, you can notice that the way the regions work is you can just set multiple cores with the same region ID, and you can even do like different shapes than a square. You just have to cover the regions with rectangles, and as long as you can do that, it is fine. So that being said, let's get to it. Now, how do we compute the shortest path? Now, normally, as you saw from the thumbnail, we will be testing by moving unit from here over here. Now you can see that it is in this region, so it knows that it can go over here or over here. And then from here it can search this way, this way, this way, and from this way here. However, it would be difficult to do it like this. I would have to probably use the Dijkstra search algorithm. I might do a video on how to do that later. But for now, I will choose a simpler method. Because the gateways don't change, nor do the regions, what I will do is I will pre-compute how far is it from each, how do you call it, point from each entrance of the way gate to each other. So I will compute how far is it from here to here, from here to here, from here to here, from here to here, and so on. So for every two like portals, I will know what is the shortest, what is the distance between them, and what is the path that the unit would have to take to go from one portal to the other. Now this will make it very easy for me, because after that all I need to do is compare all the portals on the side where I'm moving from with all the portals on the side I'm moving to, check the pre-computed distances, choose the shortest one, and take the pre-computed path that is associated with it. So the actual moving of the units will be very simple, and all the work will be, at least most of the work will be in pre-computing the distances. So let's do that. And as you can see, I did some work. I also fixed the issue when you take a unit and move it somewhere, you can actually change the direction in the middle of the gateway, and as you can see, it recomputed and now is moving in a different direction. So that's also a nice plus. So here we have the navigator script, which is this one, and it isn't printing a debug print, which is not cool. I wanted to show the debug print. Show and clear, so maybe I need to recompile. Yeah, that's possible. Units, scripts, recompile, close. Okay, now it is printing. Cool. So as I can see, it found that the unit is going from region 1 to region 1, and then it prints what is called what I call a course, like a ship going on a course. I have no idea how to pronounce that, so I will just call it a path. Now it has just one destination, the final destination. If I move it here, you can see it's going from region 1 to 3, and it has three destinations. First this point, then this point, then this point. But let's get to what I was saying earlier, and let's pre-compute all the distances between all the different entrances of the wait gate. So I will call it pre-compute distances. Now this will be a rather complicated method, so I mean function, so I will have to think a little bit how I want to do this. So how I will do it is rather simple. I will keep the shortest distance between each pair of the portals. I will just call these portals, as well as the path that you need to take between them. So for example, for these two, the shortest distance at start would be unknown, and the path would be unknown as well. But during the computation, the shortest distance will probably be this way, and the path will be like go over here, then over here, and then you are there, right? Something like that. So the first question is, do I want the first thing here to be inside the path? Maybe. But how will it work overall? Well, first the pairs of the portals will be only partially filled. That means that the path from here to here is known. It is like this, and it's simple as way from here to here, and from here to here, and so on. So like the simple path from here to here, for example, I can fill it in manually, or more or less manually. But more complicated path like this from here to here, that will not be known at the start of the path finding. That will have to be computed. Now how do I compute it? Well, let's say I know all the simple path. The path that will just have one step. For example, from here to here, just one step. From here to here, one step. Easy. So how do I compute the path from here to here? Well, I can do a really simple trick. I can go over all the portals and ask, for example, I can go over this one and ask, Do I know a path from here to here and from here to here? And if yes, I can make a path from here to here over this third portal. Now I don't know the path from here to here yet, so I just fail and move to another portal. Let's say this one. And I don't know this path nor this path. So you see that I will keep guessing and missing a lot. Again, I don't know path here and I do here, so it's useless still. However, if I check this portal, I know the path from here to here and from here to here, so I can compute the path from this portal to this portal over this one. And in the next one, in the next step, when I'm computing the path from this portal to this one, I will again keep guessing, and it will not be very helpful until I guess this portal, in which case I already know this path and it can compute this path as well. So I just continue going, and as long as new paths are discovered, and eventually I will compute all the paths that are possible. Now as you can see, if I'm computing the path from this portal to this one, I have two options: go this way or go this way. Now this way will probably be discovered first because it takes less steps. However, in general this way could be actually shorter, namely because moving through the portal is faster. So if the portal was like from here to here, imagine, then even from this point it would be easier to get here through this portal like this. So in order to take account of that, even if I already know a path between these two portals and I discover a new one that is shorter, I will replace this path by the new one. Now the question is, if I use the path between these two portals to, for example, compute the path between these two, and I just discovered a shorter one, doesn't it mean that this path should be updated as well? And that could be a problem, perhaps. However, it is not a problem, because, as I said, I will do this in steps, and let's say it's the first step. So, well, it's too complicated. I would have to explain to you the proof why this will work, but I will try to do it easily, so that you can understand with my really poor explanation somehow. In this example, this path has 2 steps, but this path would have how many? 1, 2, 3, 4 steps. Now I will also keep updating the distances in steps, and in step n, let's say I'm in 3rd step, so in step 3, between each 2 points I will have the shortest possible path of length 3. So because there is no shorter path from here to here of length 3, because this is too long, then this path is fine. However, in step 5 I will be able to discover this path, and it will still be true that I have the shortest path between these 2 portals of length at most 5. And then the next step, because previously the path here led like this, in the next step I will be able to update it to this path, because I will again be recomputing these 2 portals and be checking all of the others as the 3rd one, and I will discover this one and see that I can make the path shorter like this, and it will actually be the shortest path with length 6 or smaller. So as I'm trying to say, in the step n, let's say in step 6, I have only the shortest path between 2 portals of length 6 or lower. So in order to compute all the shortest paths of any length, I need to repeat it as many times as there are portals, because no path can be longer than the number of portals on the map, simply because if a path visits the same portal several times, then there's a loop that goes back to where it was, and you can just throw away the loop and have a shorter path. So I hope that makes sense. If it doesn't, then don't worry, you don't need to understand the proof to understand how it's computed and how it will be computed is really simple. All we need to do is a table where the key to the table or the index is the pair of the portals, again ordered. So a pair from here to here will be different from here to here. And initially only the path with one step, as I was showing earlier, like this one or this one or this one will be there. And then in each step I will go over all the other portals than the two that I want to recompute and check if I can go over the third portal and connect them. So let's get to it. First I need to somehow get the IDs of all the portals. Now what ID should I use for the portal? Well, that's a good question. Maybe I can use the ID of the unit, because if you look closely there's actually a CRPL core at each end of the portal, so I could use that as the ID of the portal, or I can use the coordinate, the XY coordinates. However, maybe someone would want to put more portals on the same spot, let's say make a hub that there would be two portals, one here and one here from the exact same spot. So I will not risk that, and I will rather use the ID of the unit. Now that has even another problem. What if someone puts like one gate here and put an endpoint here and another gate here? That will lead to it. Well, let's just put a disclaimer to not do that into the description so that players know that it will cause a problem. And let's use the ID of the actual course for the identifier of the portals. Now I need to revisit this function which connects, as the name says, the gateways to the regions. So what it does, it finds, yes, it has a variable named region edges, and it is a list, and it contains, okay, it is the coordinate from coordinate 2, this is the region 2, and it even has the ID of the, oh, it only has the ID of the gateway and not the end. So I will just do something like this. Let me think. Yeah, I was doing this off camera probably. So what is does each region remembers like this region remembers these four ways, right? It remembers the start, the end, the ID of the region where this is going, and the ID of the gateway. Now I will also add the ID of the unit that is actually in the region. Well, does that make sense? Maybe. Yes, that's what I want to do. So if this is the list one, hang on, let me check that I have this correct. Yes, this seems correct. Yeah, so I want to do it like this. So as I was saying, in the first step, let's go over all the regions. Hang on, how do I even get all the regions? refresh. Oh, I already have a variable named region cache. So that's pretty cool. However, it can have the same region ID multiple times, so I will have to keep that in mind, or do I? Well, this is this is pretty weird. Yeah, it will be fine. Okay. Okay, so first let's go over all the regions, and yes, first we need to get ID of all the portals. That will be the most important first step. So first get the ID of all portals. So I go over the region cache, which is just a list of elements that has these values copied from the region. Now I take the region ID, and then oh wait, this oh, I see yes, I will actually be using this region edges variable and reading from it these IDs saved over here. Okay, so that's pretty simple. So we are going to create list for we will name it simply all IDs or something like that. All UIDs, simple. Which will be the or even all portal IDs, simple like that. So yeah, let's go over the region cache. No, not like this. Okay, now this returns a list like this, where the 0, 1, 2, 3, fourth element is the region ID. So let me just continue immediately with for get list element. Now I have the region ID, so let's just save it. And so that the code isn't too complicated. Now let's use the variable region edges. Okay, concat and read from. Yes. And save it to edges, for example. Why not? And now let's go over all the edges and read the portal IDs from them. So again, get list count, 0 do loop, and then edges I get list element into edge, and then the portal ID is on the 6th index. So if you go 0, 1, 2, 3, 4, 5, 6, that is the index of the portal. So I can just do edge 6 get list element. Actually, let's go straight like this. Oh, I copied it wrongly into portal ID. Now I could add the portal ID here. However, I will check if it's not already in there. Right, I could do this. Portal IDs, append to list. Yeah. However, let's first check if it's not already in there. So let's make a new function which will be called inList, which will take a value and a list and return boolean if the value is in the list in question. Okay, so the question is, can I make it without using a variable? Well, that would certainly be cool. Probably not, so let's just save it. Into variables like this. Should be okay. So list, get list count, yeah. Then list get list element value equal if. So if the value is equal to some element in the list, then return false, and otherwise return true, right? Simple. So we check it like this: portal ID, all portal IDs. No, not duplicate. In list, not if. So only if it is not in the list, we want to add it to it, right? And then let's just print it and see if it works or not. Yeah, save file. So compile all, close. Oh, empty list, field back. Okay, what did we do wrong? Oh, this is the wrong function. Okay, so let's region ID, and let's trace the edges here as well, and the portal ID as well while we are at it. Okay, skip compile, because if something doesn't work, just print something a million times. Okay, portal ID is getting printed in list. So maybe this function is wrong. So first it saves the list and then it saves the value. Get list count. Oh, of course. If it's in the list, then yes, the value is true. And then the value is false, because I was already thinking about this negation, and I was negating this in here, which you don't want to do. So okay, it looks fine. Now what do I want to do? Oh yes, I want to get rid of all this. Is there... okay, this as well, I guess. That should be all. Now I have all the IDs, so next I want to... now, as I said, next I want to initialize all the distances and paths that we know about. I mean, not yet. I want to just set it to default values, like distance to -1, which will mean that we don't know the distance yet, and path to like and empty list or -1 as well, doesn't matter, which means that we don't know the path yet as well. So for that I will just do all portal IDs. Hang on. Get list count 0 do, and then straight away another time, because we need this for each pair, and then just save the get list element into portal 1 and J setlist element to portal 2. Now remember, these two are just numbers. So what we want to do, if they are the same, then we want to set the distance to 0 and the path to an empty path, which will be like an empty list, I guess. Well, that I have to think about what the path will be. I guess it will have yes, I know, the path will be list of all the portals on the path except the first one. This means that two paths will be easily combined together. So I definitely want to put how do I call it? Oh, I'm just so confused. Well, well, let's choose a name for the distance of the... okay, we have a variable name distance, that should be fine. Okay. Okay, now I am making a variable that will be named distance, then the first portal, then dash, and then the second portal, which will uniquely identify this pair. And yes, I want 0 to be written into it, so I can just do it like this. And then I want an empty list to be written into path with the same identification. However, else, let's do -1 for both of them. Because if they are two different portals, then in this initialization we don't know the path just yet. So let's just put -1 into this. Now it will do the now will come the part where I override some of these values with the simple path, with just one step, like from here to here, or from this portal to this portal. So what I need to do is find all the gateways and initialize the path between them. So we will just copy paste this code pretty much. Yes, we definitely want to be going over all the edges, but this time around I don't need to just save the portal ID from the edge. It will not be so important as the entire edge from that region. Now first let's start with just these, because that will be relatively simple. Now as you can see, this yes, one of these edges has both the gateway here and the other one has the gateway and the end. Now I want to find this edge because I need to connect these two together. Okay, where was I? Okay, here edge. Yes, so at position 5 is portal 1 and at position 6 is portal 2. Now what I need to check is that these two portals are different. Because if they are the same, then again it's like the reason for this is too complicated for me to explain, I guess. Okay, portal 2. Now what I need to do, but as I was showing you, this here is so that the gateway can get notified, so it always needs to be like the real gateway, and this needs to be the ID. So it's either the gateway or the other end of the gateway, and I want only this one where it is different, not this one where it is the same. So that's why I'm keeping it like this over here. So what I need to do now is create the way, right? So what we will need to know in the path? Well, we will need to know the ID of the unit, the coordinates, and the type, whether it's the entrance into the portal or the exit. Now why is this important? It's important for later because, hang on, I will find path. Now there is a function like this that is only more simple, and it remembers the position. Okay, there's some okay, this is fine. Oh yeah, I will need to do this as well. Well, that will be fun. But yeah, if I will be doing this anyway, that means it means I don't need to care about that whatsoever. Well, that's pretty convenient. Well, in that case, what I need to do is just keep the ID in the path. Now this will be just a simple list of IDs, of these portal IDs, and this will be just a single number of a total length of the path. So actually there should be a function make list, yeah, that receives the argument for the list and the length. So I can just go immediately like this. Now this will be the path. Now I also need the length. Now since this is the path through the gateway, the length should be lower because the unit is moving faster. And the coefficient is 2.5, I believe. Okay, so let me change this to speed coefficient. I hope that isn't used anywhere else. Nope. Okay, that's good. Because if I ever need to change it, I could run into risk of just changing it on one place and not the other, and then it would lead into some pretty bad inconsistencies. So let's just do it like this. Or you could even use it as a input parameter, so players can easily change the speed of the unit in the gateway. Ah, okay, why not? Doesn't really matter. Speed coefficient 2.5, and command will be units move x times faster in the gateway. Okay, that's pretty simple. However, I will need to now use capital S here. I just like differentiating what is a variable and what is an input parameter by the capital S here. So that's always nice. And now finally here, I will of course compute the distance between the portals. However, I will then need to divide the distance by this, because that will be the time it needs to take relative to moving on the ground, basically. So let's see, portal 1 const pixel card x get unit attribute, and then the same for y. And then the same for portal 2. And then speed coef. Oh no, I first need distance. Then speed coef divide. And that will be the distance. Now I also need the distance just once, and I need the same distance on the other way around. And finally I just fill these variables. Okay. Okay, so I definitely need distance. Yeah, I just call it dist, so everything is the same length. The distance will be the same, however, this means that it is going from portal 1 to portal 2. So the path 1 will be this one, because it is the path, as I said, the path will have everything on it except the first portal. So if it's the path from the first one to the second one, then it just has this just a list with the second one on it. And here as well. So this sets the, how do you call it? Well, I'm just, it slipped my mind, unfortunately. How do you call this? Yes, this sets the edges for the gateway, right? From this portal to this portal. So now I need to set it across the, like from here to here, for example. Now the code will be very simple. For example, this entire thing, well, except this one, will be the same. So I think I will move this to a function, which will be called initialize edge. Initialize edge, which will receive the two portals, which it should initialize, and this coefficient here. So I can basically just Control X this. And let's save the variables from the stack. Portal 1 and then into coefficient. Okay, that will this. Okay, looks fine. And then just use coefficient here. Now I can set this coefficient to 1 later and it will be fine. Or maybe I don't even pass this and just rely that, yeah, let's just get rid of this. And as a comment right here, variables portal 1 and portal 2 need to be set. So that's it for this function. Should be pretty easy. Now what I want to do here is also make a new list called local edges, for example. Now this will be list of the edges local to this region, right? So no, it will be called local portals because this will be the list of the portals in this region, right? So I actually need the portal 2 to put into the list. Yeah, here let's just initialize the edge with the speed coefficient. And also let's put portal 2 into the local portals variable. This way we can gather all the portals in this region, and what we will do with them, well, that's simple. We need to go over each pair. I mean, just loop, and then connect that pair, which will be really simple. So I can even do it like this. Except not. Remember, there could be two portals on the same coordinate, so I should not do that. I should, or should I? Yeah, I think I can. Because even if they are different on the same coordinates, I and j will still be different. So I can even write it like this. Which means I could do it like that as well. No, because okay, so I couldn't do that then. Okay, so I can do this. Okay, let me copy paste this here. Local portals, and then just initialize edge with coefficient 1, which means a normal movement speed. Now all the simple paths of length 1 like this or this or this should be set after this is called, and then we move into the final step, which will be join paths together, for example. And here is what I was saying before, that if we want this path, we will keep trying every portal until we find one where this path is known and this path is known as well. So let's do it. First we need to iterate over all the pairs. So again, let's do all portal IDs like this. And now in the inside, we will, if we have these two, we still have to iterate over all the other portals, which is like this. And as the icing of the cake, we need to repeat this how many times? Well, as I said on the start, the longest path will be only can be only as long as the number of portals. So we need to repeat this many times. Wow, this is some pretty crazy code. Now, as you can see, this could be running a rather long time. Let's say you have only 10 portals. Well, those are, I mean, 10 gateways. That would mean 20 portals, which means this would be running 20 times 20 times 20 times 20. So that's 160,000. Wow, that's pretty long. Wait, I'm pretty sure. I'm pretty sure this thing shouldn't take so long. Something might be wrong. Hang on. Let me Google this. Well, there is, there's like four, hang on, four. And where are the different? Yeah, this one. Yeah. Oh, that's right. Hang on, that is pretty simple. You know, as I was saying that from this portal to this one, we will have to check all the other portals. Well, there is actually a better way to do it. And that is, instead of that, imagine that we already know the shortest path from here to here, right? So we just check all the edges, which is all the simple. Wait a minute. Yeah, just all the simple connections, like imagine this simple connection. And if we already know a path from here to here, then we just extend it like this. And that is the only thing that we will be doing. Which means that we need to save, because it will save us from this madness, right? Because this is pretty bad. What we need to do then is like keep these simple edges separately, I guess. Oh, I remember now. The way I was going to do it, there should actually be logarithm of this. Okay, never mind, never mind. Let's just do it the simple way, I guess, which is remembering all the simple edges. So let's save it into a variable named simple edges. Alright. And every time we create one, we save it into this. Now what we will remember here is I guess just the pair of yeah, we will remember the first vertex on the edge, the second one, and the distance of the edge. So just so we don't have to recompute the distance every time. So the first is portal 1, the second is portal 2, the distance we already know. So 3 at make list, and we will put the result into simple edges. Okay, like this, why not? And also the other edge as well, of course. Now what we will do is we will still go over all the vertices or all the portals, but this will just only to count maximum number of iterations. And now instead of this madness, we will just go over all the simple edges. Like this. Now isn't that much better? It probably is. And wait, hold on. Yeah, but yeah, this only computes the shortest distances from one point. So either we do this every time we want to move a unit, or we do this for all the different portals, or we find a different algorithm that can solves all pairs shortest path. Yeah, this is the one I wanted to do. Oh, this looks good. Yes. Oh, this is bad. Oh, this is good. Okay. Yeah, blah 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 blah. Okay, let's read it. All possible graph between each. Yeah, so this is the path algorithm that I was talking about earlier. But this would suggest that you would only like nest the loops 3 times, and I had to nest them 4 times together. So I'm thinking about what I was doing wrong. Oh, I get it. So remember that I said that it will keep the shortest path that has length at most 3. So for example, this one, and in next step it would connect them. Well, it actually works differently, so that it only keeps the shortest path using the first three portals, or the first X portals in general. So if you keep only the first, let's say, 5 portals, so let's imagine these 5 are the first 5 portals, and you know the shortest path between them, so you know from here to here the shortest path is like this, and this path like this, and all of them, and you need to add a new portal. Well, then it is simple, because hang on, let me read it to the end. Return the shortest possible path from I to j using vertices only from set 1 to k as intermediate points. Oh, so this would actually know all the path that use all these 5 vertices as intermediate points, which would include path like this, or a path like from here to all the way to here, for example, and so on. Yeah, that makes sense. So if you want to add a new vertex, then oh yeah, that makes sense. What does it? Hang on, I have to think. From I to j, from I to k, from k to j. Oh! Yeah, of course. Okay, well, this is pretty simple. Oh yeah, look at it. It's really simple. Okay, from 1 to v. But hang on, how does it? Yeah, okay, I guess that works. Okay, let's just copy paste this from Wikipedia, which means that we will not be needing this, I guess. And also, instead of putting -1 to the distance, let's put infinity there. This is because we don't need to check separately if the path is less than the one we found, or if it is if we didn't find one at all, we just check if it is less than what is already there. And if we put infinity there at the start, it will mean that any path will be less than infinity. So let's go into reference and see if there is a command for infinity. Oh, there isn't. Can I do 1 divided by 0? To generate infinity, will that work? Hang on, let me check. Script compile. Infinity, nice. And just to check, see if 2 is less than infinity, just to be sure. Script compile. Yes, 2 is less than infinity. Perfect. So I can just put infinity as the length of the edges. Hang on, where is... I don't see. Find no. They compute distances, yes. Okay, we put infinity here, that's fine. And the path value doesn't matter. And yeah, this is fine. Yes. Yeah, this is only to count maximum number of iterations. Hang on, let me... Get list element into portal, okay. Here it will be into portal J. And here it will be into portal I. Now, what I need to do? Hang on, let's just... Now, where did I put the... Oh, here it is. Okay, we did this. And... Yes, now the... Okay, so we need to read this distance and this distance and compare it to this distance. Okay. So first we need to read the distance from I to J, which is in the variable distance portal I dash portal. Portal J. Okay, concat 3 times. Actually, I can save one concatenation by doing it like this, using the distance instead of the dash, because as you can see, this is inside 3 loops, so every, how do you call it, every command counts, and this will save 2 commands on one variable read. So if I do even more variable reads, it will save even more commands. So this is definitely the way to go. Yes, I need from I to K. Concat read. Okay, and then to it we add pretty much the same, except this time from K to J. And we will save this into variable dist, which will stand for maybe better distance. Again, this will be our guess for again, we are considering a path from I to j that is now going over the vertex k. So what we need to do is to get our real distance, which is from I to j. And if the computer distance is less than, this means that computed distance is less than previous distance. Then we update the distance. Now that will be done really easily. You just do this, right? Oh no, you do it like this. You save it into this variable, and that's it. However, we also need to update the paths. So maybe I will just save all these variables. Oh, it will not help anyway. So to join the paths, you just take the lists and you join them together, which will be rather simple. I will create a new function for it, which will be called join lists, and it will get two lists and return a list that will be all the elements from the first one plus all the elements from the second one. So first it will create list into new list. By the way, you might have thought that oh, I can actually clone the first list. So I don't want to just add the elements from the second to the first one, because why not again? Oh, I know, because it would modify the first list, so the next time this edge is used, it would just be broken, so don't do it. Okay, I am such terrible explainer. Okay, but I need to focus on this, so at least I have an excuse. So copy list. Okay, so first we swap so that the first list is on top, then we copy it, and then we save it as the new list. Now at this point, this old list is still on top of the stack, so we can do duplicate 0 get list count do. And as we are going over the elements of the first list, which are readily accessible here, what we need to do is put them in the new list, which at this point is just swap. New list swap append to list and pop here. Well, I don't like this swap here. It is so that I don't need a variable for the second list. But maybe if I just save it into second list here. Then I can just do this instead. Oh, I also need the 0 here, and what was I thinking? This is terrible. So new list, like so. Append to list and then return new list. Okay, let's try it out. Okay, it should work fine. So let's start with 1, 2, 3 into list 1, and then I don't know, 4, 5, 6 into list 2. Okay, let's make them a different size. And then let's do list 1, list 2, join lists, list 3, and then let's print all of them to see if it worked and if it didn't modify the original list. So trace 3. Oh, someone is... oh, it's just fine. Okay, let's go into here. Skip compile and... oh, perfect. So our join list function is working as intended. So all I need to do here is, where is it? Hang on. All the way at the bottom somewhere. Yes, here. I need to create the new path as the joint paths of the previous one. So first we need to go from I to K. Again, path instead of distance. Concat read. Then I need to go from K to J. And then I need to okay, let's even put it like this so it can be easily seen what is where. And finally I need to save the result as the path from I to J. Yeah, this yeah, write to, and the value we write is all of this. No, misclick. Okay, so now again, if we take the path from I to K and join it with the path from K to J, we get the path from I to J. But only if the distance of this path was shorter than the previous path, the previous best path that we had. So that's all. And that's it. That's the pre-compute distances done. So what to do now? Test it out? Sure, why not? So let's go to the find path function. Now, how does it work? How does this work? For now it only... okay, we will not need the region edges variable at all. Yes, we have the final step here. Okay, so all of this can go away. Now instead what we will do is... yes, we still need to do the one last thing that I said, which is... I didn't get the notification. Yeah, it feels bad. The last thing that we need to do is, as I said, check the different portals in the region of the start, and then check the different portals in the region of the end and compare all the pairs, which might be tedious, but hey, let's do it anyway. So again, let's put infinity. Oh, I just love this this trick so much, as best distance. And then let's put how do you call it? I forgot, my bad. Yes, let's put, I don't know, something -1, doesn't matter, as the best path. And now let's go over all the things, all the portals in one region and the other, and compare them. So as you can see, yeah, there is already some good code here that I can copy. So this will go over the, okay, this. So find the stuff. Okay, this will just well, as I said, at the end I will have to make it work with a single wait gate in a single region. But for now, let's skip that. So this will go over all the starting edges. So this will be like edge 1, I guess. And then we also need to go over all the target edges, which is region 2. Edge 2. So now that we know that, we need to compare the... Hang on, where are the edges created? Here. And I just need this this element from the edge. I don't care about the rest. So 0, 1, 2, 3, 4, 5. Actually, not this one. This one, 6. Oh, I will need this one as well, but I can ignore it one. This one is 6, right? So let's just do 6 get list element here. And we will save it straight to portal 1, because this will be the ID of the first portal. I mean, as this will be ID of the candidate for the first portal, so either this one or this one. And this will be ID of the candidate of the second portal, so only this one. But if there was a gateway like this, then this one as well. So all I need to do now is to check this, right? So we get the distance from this portal to this portal. Again, read the distance, and if it's less than our best distance so far. Oh, too much used to writing it like this. If and if, right? Okay, let's just make some space, because why not? If the distance is less than our best distance so far, then we save this into the best distance, and we save the path as the best path. It's really simple. So now we have our best distance and best path. Okay, I changed my mind. Let's just stick it together again. And we need to check if the best path is still -1, because it is possible that it found no path whatsoever. This would be the case if, for example, this portal wouldn't be here, then from here to here there is no path. So it would just still be -1 here. So in that case, I need to check it. Best path -1 equal if, which will be no path found, and we will do the same thing as here. We will just only do one step, which is the final step. And lastly, yes, what we need to do now is, if you remember, the path is all the elements on it except the first. Except the first, how do you call it? The first portal. So now we need to let's just do this. It will be simple. Into first portal, because as I said, the first portal on the path is actually not on the path itself, so it will be the portal one. So let's just save it separately here. It will be really easy like this. So now what I need to do is convert the path that I found to this format, which is the format that I call a course. A curse? No, not a curse. A course, I guess. Like of course, without the of, I guess. So this course has first like a list where each I mean it's a list of lists, and the inner list has the first two elements, the coordinate it should go to, then the type of that coordinate, where 1 means entrance to a gate, 0 means exit from a gate, and 2 means the final destination. That's why there's a 2 here. And then there is the ID of the gate that it is going through. Now in order to convert this, well, let's just get on with it. Why should we wait on something? So first we need to copy the path. And from now on it will just be named path. Now we also need to add this first portal to it, because remember the first element prepend to list. The first portal on the path isn't actually on the path for it to make it more easy to join two paths together. And then yeah, we need to do the conversion. So let me create a new list into course, and then do path get list count 0 do loop. Okay, and then path I get list element into, how do you call it? Portal ID, I guess. Now the portal ID will be used to get the coordinates. But first I need to get the I need to so on. Yeah, I'm just blabbering, but because it is very different how you handle the entrance to a gate and exit from a gate, I need to know if this is the entrance. And if I is divisible by 2, which is checked easily like this, then not if. This means that this is the entrance, in which case I will need to save, I will need to remember some things. For example, I will need to portal ID. I will need to get the angle of the gate for the offset. Now, when the unit is entering the gate, I don't want it to always go on the center, but to be a little bit spread out. Now, how should I spread it out? Well, I need to know the angle for that, and I also need to have the offset same at the start and the end. However, this could either be the gateway or the gateway endpoint, depending on which way the unit is going into the gate. So the question is, do I need anything except the... Yeah, I also need the ID of the gateway. So let me write a function for that, because why not? And it will be named the angle is already in this function, so I only need to convert the endpoint to the gateway in case it is an endpoint, which I guess I will just use this. So it will be just named convert to gateway. Okay, and converts gateway or endpoint to the gateway. So just save to OID. Oh, it's important to save to OID and not to unit, because unit is used here, and it must not be overridden when you call like a function over here, so your ID should be fine. So is there an easy way to check if a script is attached? Probably not. So let's try to read this variable from this script. So UID, the variable to read is gateway endpoint ID, and the script to read from is gateway endpoint dot trpl get script var. Now oh, I'm dumb, this is not the way to do it. There is yes, is gateway, this is much better. So gateway crpl is gateway get script var if. So if this is the gateway already, then we just return UID. However, oh yeah, I'll just do return, why not? However, if not, we need to... Yes. Get script var. Okay, we need to find the gateway like this, which will not be that difficult. How is get script get course with values? Just the name of the variable and the value? Is it that simple? Hang on, let me go into the RPL reference. Hang on, where is it? Get course with var. Oh, just variable name and value. Okay, that's pretty simple. So this is the variable name, this is the value. And then get course with var 0 do. Now what? Well, I can just override this UID because I don't need it anymore. And then I return it. Oh, simple. Yeah, I also like to keep it to put it like this. So it is like better, easier to read. Okay. This should do it. Yes, so I need to convert it to gateway to get the gateway ID. Cool. Now I need to use the gateway ID into the randomize2 function to get this offset. Okay, and now we are ready to create the course. So first we need to get the position of the portal. So constant pixel card x get list element, then portal ID again, constant pixel card y get list element. So that is the position. Then I need to just add the randomization. So that's pretty easy. Then I need to fix the y coordinate. Now this is because when the unit is flying like this, if I pause at the right moment, now you can see that it is actually a little bit upwards. However, the pixel coordinate is the same as if it would be on the ground, right underneath, right? But it is rendered a little bit above. Now what this was causing that the units were traveling on top of the portal, so I need to move them downwards a little bit. But well, I just realized that actually changes the distance, because if there are two portals like this at the same distance exactly, then the one on the bottom would actually the one at the top would actually be closer because the unit is going a little bit downwards, but that would be such a headache to actually take into account that I will just not do it. So fix y, and then I need to put there 1 if it is entrance and 0 if it is not. So I will just save it into is entrance. Yes. Is entrance. And then the ID of the gateway, which is here, and then for make list, and then append to list to the course list. Bam! Wow, that is some crazy code right here, but it should work. Now lastly, I need to add the final step to the course, and that's it. Just return the course and we are done. There is no way this will work, but we have to try to see what the problem is. Okay, so there is some problems straight away. Okay, convert to gateway. What is the problem? Oh, I didn't write an add here. Okay, so compilation on second try. Okay, let's see it in work. Unpause. Okay, so this works. So let's try this. Okay, let's speed it up. Okay, it's going. Oh. Wait, minus 2, minus 6. What? Okay, can it find the way like this? It says going from 4 to 6. That's pretty good. Wait, why are the coordinates negative? That doesn't make any sense whatsoever. Oh. Oh, I'm calling getList element instead of, how do you call it? GetUnit attribute. Yeah, that might be the problem. But also the course looks really bad. You stop it. What is this unit doing? It's compiled. I think I have left to destroy this unit. It's completely broken. Okay, so will it go through the gateway? It looks like it. No, it just goes straight to it. What is going on? Oh yeah, of course. No, not of course. Wait, why does the course only have 2 elements? Okay, let's see the pub here. I think that will be the most important bit. Path, trace 2 actually. Okay, so move from here to here. Okay, oh, what is it? Is it going this way? What the hell? Look, and now it thinks it's in the gateway. Wait, is it moving faster because it's in the... No, it's not even moving faster. What is going on here? Yeah, a friend wants to play Overwatch. Well, but I want to fix this first, because what is going on here? Okay, so either this is completely busted, or this is completely busted. Now I don't want to debug this. So let's debug this instead. Yes, region edges. Okay, so let's see. Better future found because I know. Best distance, best path, trace tree. Let's see what this does. Git compile all. Over here. Better future found 0, 0. What? Best path. Hang on. Oh, I didn't. Yeah, that's a bit of that's fair idea. Because this amazing idea that I had that would make the script go faster, well, it will make it go faster, but I actually have to, like, you know, change it everywhere and not just somewhere. Feels bad, man. So let's make sure that the old version with the dash isn't anywhere. Okay, looks fine. So now maybe compile, close. Oh, 1 to 2. Oh, it's going straight there. What the? Like it doesn't redirect it through the... Oh, now it goes through the vehicle. What is going on? Better future found. But how can a better future be found when there is no path? That is the question. How can... Hang on. So here it just collects the portal IDs. Well, that's fine. Here it initializes the distance to infinity if they are different, and path to -1 if they are different, and if they are the same then distance to 0, and empty list as path. Oh, maybe I messed it up. Because if the path has all the elements except the last one, and there is... No, this should be fine, it should be fine. Region cache. Edges, local portal. Wait, why do I just read like this here? This doesn't make much sense. I mean, what is this? What is this variable doing here? This isn't anywhere. There's probably some miscom. Okay, looks good. Initialize edge. Okay, so path 1 is just the path containing the second portal. And path 2 is just a path containing the first portal. Well, this looks okay. Well, it doesn't look that bad. So let me check the results. Let me check the distances and paths from the first portal, because why not? So all portal IDs. Oh, I keep messing up. So I mean 0 will be the portal 1, and I will be the portal 2. Now distance and path will be just portal 1, distance, oh, with small d, then portal 2, then concat, read from, and then the same for path. Path, reach from, and then trace tree. Okay, let's see. Zero, what is going on here? But why is it just 0, 0 everywhere? It seems like this read from variable command is busted. I mean, that's what it looks like to me. I mean, I concat twice, which should be fine. It is after a compute distance is called. So what is going on here? Let me try this. Oh, it is updating. So let's try it like this, and then portal 1, portal 2, trace 2, good one. Zero. Oh! let's pretend this didn't happen. I mean, I am live, so I would have to like cut this part of the stream and then re-upload it. Too much work. Well, at least you see that everyone makes a mistake, especially me. Okay, let's see. Okay, infinity negative one. Well, that's better. So 0 empty string, infinity negative one. Well, that's pretty bad because it means that even the basic edge isn't filled. You know that the edge that should go through the portal. So let me take a look at it. Oh, okay, this is fine. Yeah, I'll just search trace. That will be faster. Okay, I don't need this. Okay, this is fine. Okay, this no need for that. That path. Fine. Okay, relaxing edge. Yeah, this is what I don't do. Okay, so this doesn't work for some reason. Let's see why that might be. So skip compare all close. So it seems, yeah, you see these are the same, so it skips. And these are different, so it goes and processes the edge, right? So let me check this function. This might be what is causing the problem. Get unit attribute. Well, this might be fine. So let's see. Distance. Path 1. Path 2. Trace 4. Distance path. So I know what trace is which when there's like a million things being printed. Okay. Distance path. So it looks okay. Wait, why is it getting printed daytime? Oh, this is from the... Yeah, it's from later, from when... Wait, but why is it taking... Okay, I don't know what's going on, but yeah, it's pretty okay. I mean, from what I can see, it's the portal 1, portal 2. Okay, let's try this. Gate, tasty, Let's also get rid of this. And then here, let's go region trace. So I know what's up. Okay, edit. So we see gate, region, gate, region, gate, region. Now two. How can there be two pairs in region? That's impossible. Because either there's just one portal, which means no pairs. There's two portals, which means one pair. Oh no 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 no. Oh, I see where the problem might be. Well, it actually shouldn't matter, but here this will do it both ways, right? It will do one way and the other just as well. However, this will how do you call it? This will actually be called both ways as well. So you initialize it one way and the other, and then one way again and the other again. But it should, I mean, it is wasting of some processing power, but other than that, it should be fine. It should not be a problem. It should be just overwriting with the same values. So. I don't know what should be causing the issue. So let's see. The gate region. Yeah, I want to find the region that has like a lot of the. Oh yeah, this one. See, this has like a ton of. Yeah, see, this is the same distance, and these are the same IDs, but it should just get over it, and it should be fine. But why is there infinite and -1 here? That's what I don't understand. So here it is written just fine. But then here, I actually let me. Something is not right here. Let me see if I will be able to find the close. 1 2 2 1 2 2 2. So can I find it somewhere? Yeah, 1 2 2 2 1 2 2 1, and that should be setting to 5 to 55. And see 1 2 2 2 1 2 2 1, and it says infinity -1. So what is going on? Why isn't it being set? Explain. Into portal 1. Railway. I must be completely blind. Okay, that's it. What was it? 1 2 2 1 1 2 2 2. distance 1 2 2 1, right? Trace. After this is set, let's just add with one E here. I know the difference. Okay, I need to unpause and then go into it's still infinity minus 1. Okay, I don't care about this. There must be something really weird going on. So let me check. Oh, I see, I'm down. This should be switched, of course. I feel really stupid now. Okay, so maybe this is not needed here. So script compile. Unpause. Oh, now we see the distances going on, but the path is still like there is a path over here, but the joining of the paths doesn't seem to work. Alright, because it switched. First should go the value. And then should go the variable name. Like this. So now the path should be fine as well. Nice. So now it should work. Cool. And if I go from here over here? No way. No way does it actually work. Come on. Come on. Nice. Also, let's check that it finds the shortest path. So if I go here, it should probably go this way. And if I go from this one to here, it should go like straight, right? No, wait, this is shorter maybe? Wait, how is that shorter? Come on. There's no way. Over here it. There's no way this is shorter than this, right? It must be broken. Okay, so this works fine. And this one goes this way. There's no way this is shorter. Like from here all the way to here. No man, no way man, this must be shorter. So it's not finding the shortest path maybe? Okay, but that would be the problem in here, right? Better future found, that's what I should be looking at. So if I go from here to here, yeah. But how can? Wait, why are there two portals on the top? That doesn't make any sense. Oh, I know, because it like goes over here. I mean, it can start over here like this path, and then. Oh, I know. It is only computing the distance from here to here. It doesn't consider this distance and then the rest of the distance. That's why it wasn't working. So this is the distance between the portals, but I need to consider the distance from the what is it called? From the unit to the portal as well. So that's why I need to do something like this, right? So this should be yeah. I already have x from x2 and so on. That's so nice. And then portal one constant dot x get unit attribute and then constant dot y get unit attribute, and that will be into distance 1, right? Because this is the distance from the unit to the first portal. Now I need something similar here. Okay, maybe I will like phase this out a little bit. So then x2, y2, portal. Oh no, I'm just what am I doing? Yes, x2. Add y2 over here, portal 2, and oh yeah, portal 2, portal 1, and this will be distance 2. And what I want to do is this distance. That's not the real distance, because the real distance is this plus distance 1 plus distance 2, right? And this will be the real distance. And now if distance is less than best distance, then distance will go into best distance, and then the path can be read like this, so that's fine. And then a better future will be found for the unit. Okay, compile all close. Okay, it is just got bugged in the... Oh no, what is going on now? Something bad is going on. Oh no. What did I do now? Oh, I didn't call the distance function here, of course, my bad. Compile, close. Let's try something simple, okay. pull. And now if I go from here over here, it should find... No! Why? There is no way. There is no way this is actually shortcut. It must be bugged somehow still. Distance 1, distance 2. Yeah, 6. I mean, this should be fine. I still don't understand where is the problem. Distance 1, distance 2. Porto. And there's pub here, that's all you've got. Distance less than best distance. Yeah, I think this one is the path over here. Because it has 4 steps. No, it should have 3 steps. Because it was considering path like all the way over here, I think. That is pretty weird. I mean, is there... Oh, I actually muted my sound on accident. How do I unmute it? Oh, like this, okay. Well, do you see anything in the code that is wrong, if someone is watching? Because I honestly don't know what is wrong, and to debug this at this point would be like, I really don't want to do it. But if I have to, then I guess there's nothing left to be done, unless maybe add a lot of debug here. So I guess portal 1 will be portal 1 and then distance 1, trace 3, portal 2, and then distance and path, which will be the total distance, total distance and path. So that will be distance, which is just this, then total distance, which is this, and then path, which is this. Trace for. And now maybe this will let me see a little better what is going on. Compile all close. Maybe can I move this cursor so I can see better? Yes, I can. Okay, so wait for it to finish moving. Cool. So let's move this here and let's see what happens. So if I scroll here, it is from 4 to 1. This is the start. So here why is this the same? This is insane. Oh, I forgot to update this, of course. That is the reason. So scripts compile, close. Also, in order to yes, let's move this away. So that they are not in the way and it is a simpler situation. Let's make this to be sure. So we see that here is the last text. Let's do this. Okay. Now edit map, and here is the one from 1. This was this unit that I moved here, and this is 4 to 1. So this unit is moving from region 1, which is this one, to region 4, which is this one. That's good. So first it is checking. I think this is the direct. Yeah, because the IDs are next to each other, and then the path is. Hey, what is this? Oh, it actually might be the path to this one. So it is better than infinity, so it goes on. Now this is just the path directly to this, and not like over here, but just directly to this. And it says better future found because it is better. But distance, this is 360, and this is distance only 80. Well, there shouldn't be such. Oh yeah, because it was the distance of the path, and the path from here all the way to here. Well, that's pretty long. Okay, that's fine. Okay, so next is a three-way path, which could be this path, and that has distance 365. Well, that's pretty weird. That is, and the total distance is like really large. What is going on? Oh, there is like a really large distance to one of them. Oh, and here too, it's like 1000. And here too, it's 1000. This distance here is completely busted. What is going on? So X from Y from. Okay. Oh. Oh, these coordinates are in cells, aren't they? Yeah, I'm pretty sure these are in cells. Yes, these are in cells. Okay. So that's the problem here. So how do I fix it? I don't know. Salty pixel maybe? Oh, I see now. I'm just getting the just coordinate and not pixel coordinate. And but that wouldn't explain why the distance was like 1000. Well, doesn't matter, it was wrong anyway, so yes, I was getting this distance in cells, and the other one was in pixels. So the other one was like 8 times more important, which is really bad, because of course if the distance through the tunnel is 8 times more important, then the rest of the distance barely matters. So now it should be fine. Maybe. Let's see. Oh, you can see it already traveling this way. So now it goes this way correctly. And this should still go over top, right? No, it goes bottom. Well, that's weird. Because this way it is definitely faster. And it's going bottom for some way. Okay, now we have the opposite problem. Now it's going this way over instead of this way. Am I sure these are in cells? Yeah, I mean it says I here, which means integer, so it should be in cell, but I wrote that, so now. Line intersection, yeah, it is, yeah, pick, it even says pixel to cell. Wait, what? This must be some kind of map. Oh, I see. The position from is in pixels and the position to is in cells. Okay, I'm just throwing my hands in the air, and okay, I'm not fixing this. I'm just converting this to cells, because this function says it is taken in cells, and I'm converting it back to pixels somewhere over here. I don't even care. I just want it to work, so unpause. Okay, so from here to here it should go bottom, yeah? And now it should go top. Oh, it's actually finding the shortest path. Wow. So, and here to here, now watch. Here it will be fun. Bam. Infinity, -1. So, by the way, this is what happens if no path is found. It just goes like infinity and nothing to do. But this one, hey, hang on, you have. Oh, there is not even a region here. Wow, this is funny. I think you shouldn't do this. You shouldn't have a gateway that doesn't lead to a region. It is bad. But let's fix that. Let's build a core here. Okay, so the regions are 1, 2, 3, 4, 5, 6. So this will be region 7. Region ID 7. And the size will be, okay, let me write it down. So from 180 and 131 to all the way to the bottom, which is 255 and 191. So let's paste it here. So from 180, 180, let's just do this just to be sure. 131 and into 255 and 191. Apply and recompile. Now don't let this fool you. You need to recompile everything, because you need to recompile this that will actually register the region. Unpause. Oh yeah, there is no path from this middle region to this one at this point. That is why the unit is not redirected, because again, it cannot find the path. But it should find the path from here to here. Yes, wow, you can see the path data is rather interesting. So let's see it go. So now it should get redirected here. Now what happens when I change the curse inside the gate? Yeah, we will see. Once it exits the gate, it will try to recalculate. Also, you should not put the gate so close to the edge like this. It could cause problems. Because it takes a while, especially as I said, the unit has like randomized position. So if it's traveling on this end of the gate, and it arrives here, and then it takes a while to recompute, it could actually be outside of the region, and that would be bad. So don't do that at home. But as I said, if the unit is going here, and I redirect it inside the gate, okay, now you can see it. But if I redirect it here, for example, then it just recomputes and returns back. Okay, so I can go here and it changes again. I go here, it starts going here. If I go here, it goes here again. Now it goes here again, and here, and so on. So you can see it. Wow, I actually like it. And now it cannot find a way, because there is no way. Well, I must say I'm pretty pleased with this. Maybe I should try. Okay, this was a better example. Yeah, let's see, edit map. Let's move these gates around. I mean. So you always have a. Wait, did I move this gate? Yeah, I think oh, here it is. So you always have a way somewhere. So this should go over here. This can stay, and let's add a new gate here, because why not? So adding a new gate is really simple. You just build. You have to ensure that it has unique ID. So how many gates do we have? 1, 2, 3, 4, 5, 6. So this will be ID 7. So you do gateway ID 7, apply and recompile, and this will be gateway endpoint 7, apply, recompile. Now also compile all, so that the gateway is registered, and bam. Now these units should be able to go anywhere. Oh, they detected that. Wait, I want to try something. I want to put lots of units here. Okay, let's not do this one just yet. And I want to select all of them, send them here, but have half of them go this way and half that way. Well, that would be awesome. So hang on, can we go at 4 times so that the units will be there more quickly? Okay, so let's go back to 1 and let's try it out. So can it happen? Now they are all going top. So maybe if I move them very close to here, maybe that will make some of them go on the bot line. No, they are still not going. Okay, so let me put this gate a little bit closer. Hang on, where do I? Oh yeah, I just move it. Oh, don't worry about the image. It will be recomputed. Compile all, close. Okay, now maybe. Oh, so cool, so cool. Now they should arrive at approximately the same time, because if just this small difference made the difference. Oh, that's so cool. Look at it. And they will arrive here because from their own is the same path on the same time. Wow, that is so cool. Look at it. And now they enter the gate and they continue and then they go back. Okay, let's move these two there as well. Oh, look at it. It has to go all the way here. Then it continues. I mean, this effect is like really poor. But hey, I'm not so much for visual effects, as you probably know. Okay, so let's wait for this one and let's send them back and see if they split here. Oh, I am enjoying this way too much. Okay, so around here should be fine. Okay, so they are going. Okay, so what did I say? That I want to make also a gate work inside the same region, right? Well, that would need some actually, would it? Yeah, it would need some change to the code. Okay, let's actually try this. Let's add one gate into the same region, like from bottom to top, and let's see if it works. Or from here to here, and see if from here to here it will reroute it through the very same gate. And if it doesn't work, then I will just move on. I mean, I will be ending the stream either way. I just want to try this as the last thing that I tried today. So again, what is the ID? 1, 2. Oh yeah, they split and now they will be arriving at the same time. Cool. So 1, 2, 3, 4, 5, 6, 7. So this will be gateway 8. So let me add it. Yes, gateway, and oh, I don't want to add it twice now. So 8, and this will be gateway gateway ID 8. Apparently compile. So skip compile, all close ban. So first let's see if it will reroute a unit just like that. Let's also move unit here. So will it reroute? No, it will not. I think there is a check that if the unit is in the same region, then it will just how do you say? It will just go straight and it will ignore the gateways altogether. So if I go here, it should reroute it. No, it doesn't. It goes straight here. It doesn't try to go through this. It's a shame. So if I go from here to here, will it go through this gateway, which is definitely faster? No, it doesn't. So it seems that the gateway inside the same region unfortunately doesn't work at all. But it shouldn't be that hard to fix it. It's just it's all for today. So one last thing that I forget. I also will need to fix. Oh, as you see that it was a little bit weird there. But as you can see, it does work for guppy sets as well. If I send the guppy here, it will. I mean, you can see like the rotation is wrong. Like the game is trying to move it this way, but I'm messing around with it, right? So yeah. But it works pretty well, right? Return to base again, except for the rotation. It works pretty fine with guppies. But with this, it is worse, because you already saw that there was something wrong, and then this happens. Now, quick explanation what is going on. When I move the unit and I move it elsewhere, you see that it every time I move it, you see the boot that you see, which is used to calculate it. Well, the game expects the unit to go in a straight line. So when I say a different direction, it goes in a straight line. And then the game teleports the unit a little bit to the side. And it still expects it to go in the straight line. So it computes the intersection, right? Now, however, if the unit is turning, then it completely throws the it completely breaks the algorithm when the unit is turning like this guppy, right? If I send it away, you'll see that it is just passing out. And there is an easy way to fix it. I just don't want to fix it right now because I'm tired. But thanks for watching. Maybe I will finish this off Steam and upload like a test map. Just to test the feature, I'll just put some random emitters there. I'm not really good with making maps, so don't expect anything awesome. but just something basic that would show the feature, and let other map creators use it. If someone more skilled than me that could actually put it to good use. So for now that's all. Thanks for watching, and see you next time. A professional stream and hang on, oh here is obvious. Bye.